Okay, so give me 1 second. All right, so like I said, the mini lesson for today is all about distance, rate, and time equations. So very applicable to the real world around us, okay? We always are measuring distances. We're measuring how fast something moves or how fast something travels, how long it takes for something to travel or move over a certain distance, right? You can relate this to several examples out in the real world and apply it to your everyday life, okay? So the equation that we use is the distance is equal to the rate times time, okay? So how fast something travels for how long something travels is how much distance it's going to cover, okay? And you're going to hear words that are going to be big triggers for you based off of what you need to solve for or what you are given. Distance, a lot of times it'll ask you like how far, right? Or what's the length that something travels, okay? Rate is how fast something travels, right? And a lot of times that's written as a proportion, which we started to work on before. For example, miles per hour, feet per second, right? Those are all rates, okay? How fast something travels, the distance something travels over a certain amount of time. And then time, obviously, is going to be how long something travels. So whether that's in seconds, in minutes, in hours, in days, weeks, whatever it might be, some unit of time, okay? So distance is equal to rate times time. Distance, how far something travels, or the length of something, how fast is the rate, and then time for how long, okay? So let's just dive into an example. We'll see how we set something like this up, and then we'll look at 2 other examples that hopefully solidify this point for us, okay? So the first example, Nick traveled 12.8 miles in 2 hours. How fast was he moving? 12.8 miles in 2 hours. How fast was he moving? So the big note that's being made there underneath is we need to think about what it's asking us to find, right? And we're going to use some of that language from above to see what we're finding. So how fast was he moving? If we're thinking about solving for how fast something moves, that means we're solving for the rate. So that's our unknown value right now. So what we're going to do is we'll set up our equation, and our equation is not going to change, right? It's distance is equal to rate times time. Okay. And then what we're going to do is plug in the rest of the values for D, R, or T, right? So like I said, our unknown value is how fast. So we're going to leave the R alone because we know that that's our rate. We know he's traveling 12.8 miles. We don't know how fast, but we know that he does it in 2 hours. So I'm plugging in all the values that I do know, and then I'm going to solve for the one that I don't, right? So I have 12.8 is now equal to 2 times R. If I want to get that R by itself, right, I'm doing multiplication. I have to do the opposite. What's the opposite of multiplication? Division. So I'm going to have to divide both sides by 2. Okay. And then I'm going to be left with R is equal to 12.8 divided by 2. And somebody either using Desmos or a calculator, somebody tell me what 12.8 divided by 2 is going to give me. 6.4. Good. And I think somebody put that in the chat as well. Nice job, Shana. So 6.4. All right. What's that? What was the problem just now? So this first example right here. So it says Nick traveled 12.8. Oh, we're doing division, yes. So when you're trying to get that variable by itself, you're going to divide on both sides. So 12.8 divided by 2 was that problem. So then I found my rate is 6.4. So what that's telling me is I relate it back to the situation, right? As I relate it back to the example, is that he traveled 6.4 miles per hour. right? That was his rate. That was the unknown value that I now found by setting up this equation, plugging in the variables that I did know, and then solving for the one that I didn't. So this would be your final answer. So if they ever ask you to find, how fast something travels, you're finding your rate, you would set up that equation, plug in your values, and solve. Okay? Any questions about that first example? All right, second example. It says a deer is walking in the woods for 7.68 meters at 6 meters per minute. How many minutes did it walk? Okay. So if it's asking me how many minutes, what does that refer to? Does that refer to distance? Does that refer to rate? Or does it refer to time? Time, right? So how many minutes? How long did it travel? Or how long in this case did it walk? So I'm going to have to solve for time. It's something that I don't know. It walks in the woods for 7.68 meters. Is that distance or is that rate? Distance. So I have D equals RT. I'm going to plug in 7.68 for my distance. It travels at 6 meters per minute. That's my rate. And as we said as a group, we don't know the time, right? So that's my unknown variable. Just like in the example before, how do I solve for time? What do I have to do on both sides? What's that? You have to divide, right? I have to divide both sides by 6. So these 6's will cancel. I'm left with T is equals to 7.68 divided by 6. And somebody on their calculator, on Desmos, whatever you need, wherever you're using, excuse me, what's 7.68 divided by 6? 1.28. Good. So T is equal to 1.28. That's my time. And it asks me how many minutes. So let's make sure that we also include that it's 1.28 minutes for our time. Okay. Any questions about that example? Okay. Last example, it says construction crew builds a road at 7.92 kilometers per week. 7.9 or 17.92 kilometers per week. What is that? Is that a distance? Is that a rate? Or is that a time? So it says 17.92 kilometers per week. Is that a rate? Is that a time? Is that a distance? So there's a distance involved. So it's a rate, right? Because it's over a week. So 17.92 kilometers per week. Ryan, is that what you're going to say?
Yeah.
It's a rate, right? Ask us how much road has been built after 7 weeks. So how much road am I going to be solving for distance? Am I going to be solving for time? Am I going to be solving for rate? So if they're asking me how long did they build something, what am I going to be solving for? So, okay, so I can see why you said that. So, but they're asking me how much, all right, so how much road has been built? So that's not going to be measured in time. It's going to be measured in distance. Good. So I start with my original equation, D equals R times T, right? Like we just said, we're asking what's the distance of the road that they build. So distance is my unknown. Yeah. The rate we said was 17.92 times the amount of weeks that they're asking us. So it's times 7, right? Because that's what they're asking after 7 weeks, how much road is built. Well, somebody on their calculator or whatever you're using to calculate here, what's 17.92 times 7? Anybody have an answer? 17.92 times 7. $125.44, is that what you said? Yeah, exactly. So for 125.44 kilometers, that's how long the road was built after 7 weeks. All right. So sometimes you're going to have to divide to get the variable by itself. Sometimes the variable is already by itself, like when you're solving for distance. So you just multiply the numbers together. But essentially, the toughest part about this is to understand what's given to you versus what you're trying to find, right? Understand some of the language that you're going to see. How far was something? What was the length of something that was built? How fast did something go? You're going to solve for rate. How much time did it take? How long did it take? Something for time. Okay. So, does anybody have any questions at all about this little mini lesson on the distance, rate, and time equations? We feel confident that we can be successful with this, right? Just matter plugging values and solving, okay? All right.